ladies and gentlemen. A very warm welcome to one and all gathered here to become a part of RedTeam Summit 2021. On behalf of RedTeam Hacker Academy Private Limited, I wish to welcome you all, the respected dignitaries and participants present here to RedTeam Security Summit 2021. And a very warm good morning and good afternoon to all the participants, viewers from all over the globe. And I welcome our chief speaker of this session, Mr. Amit Muzail, sir. Welcome you all to the grand event of Red Team Security Summit 2021. Myself, I am Jazila Vengat, event coordinator at Red Team Hacker Academy Private Limited. We are glad to host such an efficient cybersecurity geeks at the Red Team Security Summit 2021. A warm thank you to the event planners, production crews, and to the audience. You are the fabulous people over here. A massive thank you to all our event partners, supporting partners, community partners, media partners, and tech partners for this year's Red Team Security Summit 2021. We are grateful for your continued support of this essential event, which continually challenges young security professionals across the globe to develop their skills and gain the practical experience needed in this industry. We hope you enjoyed working with us on this year's event and look forward to working with you in the run next years also. So now to begin with today, it's a great auspicious day for all of us. We are honored to have the evangelist and the speaker, Mr. Amit Muzail, sir, on this very special occasion. It is indeed a special privilege and pleasure to welcome Mr. Amit Muzail, sir, to deliver this speech on the topic Building ICS and SCADA Security Lab. Welcome, sir. So to begin with, let me introduce our honorable speaker of the day, Mr. Amit Muzail, sir. First of all, he is an experienced security professional having more than 19 years of experience and been in Kuwait Oil Company, Emerson Innovation Center, and MNCs such as Caterpillar in USA and Nokia in the past. He has completed CISSP Associate Certification also. We are very grateful to you being with us, sir, in this great event of Red Team Security Summit event history. I hope this session will enhance the brain of all the participants and audience in the Red Team Security Summit. So now you can present your speech on this topic, building ICS SCADA Security Test Lab. Sir, the stage is waiting for you, sir, and you can start to share your video and screen. Thank you so much, sir.
Thanks, Jazila.
Thank you.
You can hear me, right?
I can hear you.
Okay. Good afternoon, everyone. I take this opportunity to thank Red Team Security Summit and Red Team Security Academy for providing this opportunity of public speaking on this SCADA security topic. Let me share my screen. Okay.
So it's all
right.
fine now.
Okay. Okay, so the topic for my today's discussion is about building ICS SCADA cybersecurity testbed. Considering the wide variety of audience, all the way from fresh graduates to the experts, I'll try to keep it super simple so that everyone has some or the other takeaways from this discussion. Well, this is the agenda of today's discussion. I will be covering all the way from basic introduction to my perspective about IT/OT cybersecurity in critical infrastructure. What all different cyber attacks has happened in the world? Why do we somebody need the SCADA testbed? And what all different options do we have for building the SCADA testbed? Well, it will be from all the way from just simple simulators on the PC. Windows-based PCs or some kind of virtual plants. Mini kits are there. Some vendor-provided kits are also available. You can build your own custom kits. What's the pilot plant definition of pilot plant and how it can help? And then the national level SCADA test bed, which some countries have developed, and in India we also need some kind of national level SCADA test bed. And then what are different projects somebody can do in this kind of test bed, which can be used for the research purpose or upscaling purpose as well. For the audience who is not aware about what is ICS SCADA, what is PLC, what is DCS, this is a quick introduction. So critical infrastructure cybersecurity, or ICS SCADA security, or OT cybersecurity, is applicable to all types of critical infrastructure. That will include nuclear power plants, water management system, wastewater management, oil and gas. Then you have chemical plants, pharmaceutical industries, building automation systems. Like in Dubai type of city, there are smart buildings, so there is a lot of industrial control system being used there. Then renewable energy sector, food and beverages, or automobile sector. Take example like telco, food, these type of companies, or electrical grids. And all of them has they have suffered by some or the other cyber security attack. I will be covering those attacks. Those critical infrastructure, earlier days, they were operating in a different fashion, but with the lot of smart equipments coming also into the picture, they are becoming somehow loosely connected to the other enterprise networks and other networks, and then the attack surface is increasing on those critical infrastructures. So this is what the critical infrastructure has grown these many days. uh, all in all, industry 1.0, 2.0, 3. And 4.0. Long time ago there was a manual production. Then if you see with the with the take example like Germany, they have evolved a lot in industry 3.0, and then the SCADA and DCS, these kind of computerized equipment came into the picture. And now we are in the age of industrial IoT. So IoT has two verticals. One is commercial IoT and another one is industrial IoT. Commercial IoT is, you can see a lot of equipment, stuff which we are using in our day in day out like smart fridge is there. Any kind of smart equipments which we are using our day in day out, like those are all commercial. Industrial IoT is big brother of ICS SCADA or OT. ICS is nothing but industrial control system. SCADA is something which goes into the field, and there is something called as DCS. DCS is a bit advanced. SCADA is very old. Take example like SCADA, there is a pipeline, oil pipeline, going from one place to another place, and a lot of RTUs are installed. So it there are sensors, and it captures the data, and then it integrates with the DCS also. So look at this diagram at the bottom. There are levels in your OT environment: level 0, 1, 2, 3, 3.5, 4, and 5. So level 0 are sensors, level 1 are PLCs, RTU, any types of controllers basically. Level 2 is site specific equipments, and then level 3 you can consider as a plant wide. So at level 2 basically you will find HMI, data historian, engineering workstations, all of that. It is particular to that side, and plant wide is the plant wide equipment will fall at level 3. And there should be a DMZ. This is the Purdue level, famous Purdue level, you must have heard. And in today's world, practically it is not possible to air gap these systems. Air gap is myth. There are a lot of ways to bypass the air gap, and supply chain is one of the best example that people can bypass the air gaps also. There are many vulnerabilities. I'll not go into those things, so let us directly jump into our topic also. So this is the last slide on the introduction. What are different attacks has happened on the critical infrastructure? So there are attacks on pipelines. Stuxnet, you must have heard about the attack on Iran's nuclear power plant. Saudi in Saudi Aramco, there was an attack. Shamoon. It has reached to the mostly to the IT environment, to some extent to the OT. Then there are other malware like Havoc, Black Energy on Ukraine's electrical grid, German steel mill. They also suffered the attack. Triton and Trisis is the attack in which it was attack on the safety. The entire plant was operating without safety system in place. So it is as good as, in a simple analogy, like I'm residing in apartment in a building and there is a fire system. So that fire system works as kind of a safety system to me, and somebody has compromised that system and I'm not aware. Similar fashion, this Titan crisis attack, it was a state-sponsored attack on one of the refinery in Saudi Arabia, and safety system was compromised. In the recent months, you must have heard about Colonial Pipeline attack. You must have heard about the attack on water management system in USA, in Israel. So somebody has changed the chlorine contents in the drinking water, and then that water is getting distributed to the rest of the city. So critical infrastructure needs a lot of protection uh, with the recent advances which hackers are doing in this field. So that's the reason we need some or the other kind of test bed which will help us to grow the technology. This type of test bed can be a simulated environment of the real world environment. It's a representative lab also, you can say. uh, in the end, I'll come up with some challenges. What challenges you will be suffering. It's very difficult to really make the real world environment, but to some extent we can do. Then the new workforce which is entering into ICS SCADA security, they can get hands-on exposure. This lab can be used by research purposes by PhD candidates, developments of new technologies. Uh, from secure point of view, defense in depth, or then from monitoring point of view, OT visibility point of view, or any offensive attacks also 0 days. It can be used for upskilling purpose, obviously. Can be used for conducting CTFs, and there are a lot of products being used in the OT environment. Those products also can be tested for their security levels. So there is a standard by name 62443, and it also mentions about the security levels. There are labs in the world who are testing those equipments under the ICS Secure program, and this lab also can be used for doing more testing onto this ICS equipment. And sky is the limit; many things can be done in this lab. So how do we start with this trade base? For sure we have to think big, but we can start small. If we start with some basic virtual virtualization options, any kind of simulators, and then go towards the physical world, that will help us. So there are a lot of simulators and available. And physical, basically, the reason being physical here is all those the in ICS OT world, there is a physical process at the bottom, and then on top of that the sensors are getting installed, and then controllers, and then HMI data. Now what is physical process? Physical process is as good as, I can give you some example, like shampoo manufacturing or pasteurization industry, where you have multiple different reactors, or chemical plant. Different chemicals are coming from different equipments, they are getting mixed and going into some pipeline. Somebody has to monitor the process. uh, so if we want to have a real representative lab, then we have to have some kind of physical process in a lab type of environment. And some universities in the world, they also have created this type of environments. uh, so that's the example of the physical process. And more we move from the virtual to physical, the cost will obviously grow, because we have to bring in the mechanical, then additional instrumentation, uh, for including the safety instrumentation for these type of plants. So here are some of, so I'm going from the simulator level to all the way to national, building the national level SCADA test bed. So there are simple utilities. Somebody just want to start with the whatever resources you have, just a simple lab. You have a laptop or multiple simple small lab. You can start playing with different protocols. First of all, in ICS, there are various protocols. There is a difference between IT world and OT world. In OT, you have Modbus TCP, Ethernet IP, Profinet, Profibus, Foundation Field Bus. You have DNP, ICCP. These are various protocols. On the wireless side, in the industrial, you have wireless HART, Zigbee, Bluetooth, industrial Wi-Fi, some RF, uh, various wireless protocols are also available. In electrical grid, people are using IC104 as well. So somebody should have hands-on knowledge about how the protocol also works at the packet level. So if you start playing with some of the utilities, somebody will slowly gain the knowledge how the protocols are working. So these are some of the examples of the simulators focusing on different protocols. This list is very small. It can be grown to a very big list. So in Modbus you have Modbus PAL, MBT Gate, ModScan, DiaxLev for doing the ICS pen testing on. You have Modbus VCR. Sematic is basically by Siemens. They have TI portal along with net to PLC SIM. OPC is another protocol which comes little at level 3 and above. If you want to play with OPC, you can use some of the OPC simulation server. There are SCADA BR, free SCADA, open SCADA, you can simulate. So you just have to play around with a lot of different utilities and make your own simple simulated environment so that you get hands-on on different protocols. Um, as an additional note, there are vendors in this field. The names of the vendors are like Emerson, Honeywell, Yokogawa, GE, Siemens, Phoenix Contact. A lot of them are having their own protocols also. And then somebody should start getting the hands-on knowledge about various protocols. The next levels somebody can go to is basically some kind of available plants. People have made some simulations. Graphics is one of the simulation by one of the university based out of USA, Georgia Technological University. They have this chemical plant. You can add additional protocol support into this chemical plant. So this chemical plant is, there is a you can see a virtualized process here where there are two tanks, purge and product, and there is a simulated PLC, virtual VM for that PLC is also available, and then the third VM is for the virtual HMI. So first make the basic test bed, and then you can start doing the basic attacks on Modbus type of protocol that Modbus MITM they have explained, and then you can grow these type of chemical plants as well. Another example is bottle filling plant. It's basically you can play with the bottle filling plant. You can overfill the bottles. So there are different types of attack. Stop the conveyor belt. You can overfill the bottles, and there are some scenarios, attack scenarios. They have also developed. This is available on the GitHub. Another thing, you can play with the Raspberry Pi, and you can use Open PLC, and you can make your own simple setup. So this is another the list will grow very big. So simulators is one option. Virtual plants, I have shown you another option. Third one is mini kits. There are a lot of mini kits available in the market. Take example mini conveyor. So you can buy this mini conveyor, and there is a conveyor belt, and there is a part getting manufactured like in a robotics company kind of thing, or conveyor belt, and then the part gets dropped into some section. You can develop some physical attack scenarios, and instead of part going into section A, it will go into the section B. So that kind of attacks you can do. Or on mini warehouse, somebody can it's a warehouse and there are a lot of compartments into it. So you can play with different parts are stored into different compartments, and you can mess up with those physical processes. Manufacturing, there are mini manufacturing facilities available by some German based companies kits. Those will cost you around 2000 to $3000 as well. There is a robotic arm also, or mini manufacturing facility. You can play with those type of kits. Cybati type of kits are also available as a learning resource. It's a traffic based lighting model, and then you can play with the smart lighting system, which is part of your smart city. So you can play with those kind of kits also. Other than that, there are a lot of 3D printed kits readily available, or you can build your own 3D printed kits also. There are some companies, they have built their own kits. It's like a mini airport or mini railways, mini metro kind of thing. They have built their own 3D printed kits. The vendors names which I mentioned to you, like ABB, Honeywell, Yokogawa, most of them are having their own vendor kits. So take example, Siemens has this latest series, micro series, 820, 850. Those kits are also very useful for somebody to play around with ICS protocols and understand, start with the basics. Other than so Allen Bradley 850 and Siemens. Siemens also has, I think, 1500 series starter kits are also available. Another option for is do it yourself. It's like buying the assembled. It's like buying the branded computer versus buying the assembled computer, old age kind of thing. So you can do your own custom kits also. Some of the ideas, basically you can play with the coffee bean roaster, or make your tower crane with some industrial RF controller. You can play with the RF vacuum gripper robots also. You can play with the robotics and do some different attacks. I'll come up with the list of what all different things you can do on those attacks type, transportation models or microbrewery. And then next version of the lab would be something like a pilot plant. I'll show you some picture about what is a pilot plant and how does it look like. And national level SCADA testbed is something bigger than that, which would be sponsored by very big agencies in the country, and that can be focused on different sectors. Take example of electrical grid power sector, and those type of national testbed can be also be used, which can be a good collaboration opportunities between different entities inside the particular country, and can be used for threat intel sharing as well. So this is an example of the pilot plant. So out of our list, I'm jumping to the pilot plant. So people have developed various models on the pilot plant. Take example of water model. Uh, so like I mentioned, you have various sectors: water, wastewater, chemicals, pharmaceutical, electrical grids. We have to start with some kind of theme. On the right hand side, I have explained some of the uh, one is physical equipment, physical, and then another is instrumentation, and then your offensive tools will start. You have to build. Somebody has to build offensive tools, then monitoring tools, and then defense in depth. So on the domain point of view, basically you will need, from the instrumentation, you will need some sensors, field instruments, actuators. You will need some kind of controllers, PLCs. If you want to, there's something called as batch processing, continuous processing, or discrete. You can define your plant and make your plant accordingly. You can buy some HMIs. Try to make this lab in a vendor agnostic fashion, and try to use virtualization and open source also as much as possible into this type of. There are a lot of industrial IoT gateways are also available. Many companies are there on industrial IoT gateways, including Immersion, PTC. So those gateways also can be integrated into your environment, and you can take the data, push it into the cloud. That can be done. Some industrial routers, industrial switches can be purchased. Um, a reference to the slide, my beginning slide about the levels. You will need application servers, alarm, engineering workstation. If you want to integrate this environment into your SOC, you will need some SIEM solutions, antivirus deployment server, remote access solution. If you are building it for some university, you have to give remote access to the students, and how you can do in a secure way. That POC also can be done. And you always use the virtualization and PLC simulators. Wireless sensors gateways also can be used. Safety instrumentation, you can keep it aside in the beginning. That will cost you more. But if you want to do any research on the safety side, well, that's also a good option for you. There is an example by, I did not include other countries like Turkey and Singapore. This is an example from USA. USA has 5 labs. Here I have mentioned only 3, I think. So there is a PNL, INL is Idaho National Laboratory, SNL is Sandia National Laboratory. They are focusing on electrical grid. INL is at least focusing on electrical grid sector. This is a good example that how in different governing bodies inside that particular country can collaborate together for and for sure in India also we need this kind of test bed. Europe also has some different entities. Those are focusing on they have different types of test beds. In Middle East, I heard about Qatar, at least I know, and in Singapore there is Singapore University, SUTD. They also have this kind of test bed available with them. Coming back to now, my first column out of this is basically you have to have domain point of view with the test bed, and then the right three columns they are focusing on the cybersecurity portion. So once you have your test bed ready with virtualization or mini kits or whatever you choose for suitable for your requirement, then you can do on offensive side. You can do anything on the product level security. You can do on the system level security, and you can do on the network level security. These are the three major distinctions, all the way from hardware to cloud: hardware, firmware, HMI, protocol fuzzing, wireless, and there are exploit packs also available. Agora is one exploit pack. You have to purchase it. Metasploit also has some modules available. On the visibility on OT monitoring, you have there is something called as passive scanning. In the IT world, active scanning is famous. In OT world, we cannot do active scanning. There has to be a selective active scanning, or it has to be done on the backup systems. If somebody has these kind of labs available, uh, to some extent, then in that environment, a new approach also can be developed. Uh, you can integrate your passive scanning tools. Passive scanning tools will do the packet capture from the OT environment. It has its own algorithm. You can develop your own algorithm also. It's a lot of work there. I will come to some open source tools also. I'll tell you, including there is Snort, Suricata, Security Onion. You can use Malcolm, then Network Miner, a long list of tools, and no silver bullet. And you can develop your own approach, integrate it with the many famous SIEM tools also. Somebody wants to do more research on the security automation and orchestration, you can work with that asset. And then this entire thing needs to be done integrated with the OT asset management tools. You can have your honeypots and generate the internal threat intel as well, and that can be a research opportunity. On the defense side, you can play with the firewalls, try to bypass firewalls by doing various different types of attacks on existing firewalls. Some of the firewalls they have additional industrial protocol support, which is focusing on Modbus or DNP. Cisco has those firewalls. Palo Alto has those type of firewalls. Storm Shield has those firewalls. If you want to do POC or compare different type of firewalls, this testbed also can be used for doing those activities. There is something called as unidirectional gateway in the OT world. Unidirectional gateways are whatever data comes from the OT environment level 0, 1, 2, it needs to be transferred to the above levels in a unidirectional fashion. No single packet should come from top to bottom. There is a condition is applied there. There are it's a debatable topic, and then you need two different routes, and then how the unidirectional gateways will put the value into your environment. So you can build your own low-cost unidirectional gateways. Also, people have done some research using Raspberry Pi, and some people are working on those unidirectional gateways. Another thing is secure remote access solutions. You can work on those POCs, whitelisting tools. Uh, so whitelisting and host-based intrusion HIDS both are really needed, and you can see the value of these type of tools into your OT environment. So this will give you a holistic approach to look into your OT environment from people, process, technology. I'll come into the end about how should we really look into the OT environment from a holistic point of view. So how can we secure the existing environment? How can we implement the OT visibility? And then what are different offensive stuffs we can do at what level? That also we will discuss in the end if the time permits. So if we start from the bottom level, hardware security, you can do attacks on level 0, 1 devices. At the end, these are all embedded systems. If you see, embedded systems is at the core, and which is giving the three forks. One fork goes to the IoT, I can say, IoT or industry. Then another fork goes to car hacking type of people are working on the ECM. There are also, and third fork goes into ICS and industrial IoT security. So they, at the bottom, these are computers. These are mini computers. These are embedded systems with microcontroller, flash, it's its own architecture basically on a different processor like ARM and MIPS. So from the hardware security point of view, if you can see, there is a PLC in my hand. I hope you can see. So I'm just showing it in front of the camera. This is one PLC. There is one more PLC by Siemens. They are all simple equipments. The OT world is at least 15 years behind. So yeah, these products are never designed from keeping security in mind, both at data at rest, data in motion as well. So it is easy to hack, very easy to hack the PLC at a product level. But if you are thinking from a holistic level, how you are making your layered wise approach, that's a different discussion. On the product level, you can do hardware recon. You have to break open the product, just unscrew it, find out the PCB, get the technical manuals about the product, find out various chipsets, data sheet, do the active recon, try to gain the access to the device. There are various debug ports available like JTAG, UART. You can start communicating with the device, find out the baud rate, try to get the access to those devices. There are RTUs also. You can play with the RTUs. You can get the firmware. Sometimes some companies have made their firmware available on their website, or you can get by another sources, or you can download the firmware also from. There is something called as Modbus staging. So in some controllers, they are coming with the free memory, and people have played with, people have put the malware inside this free memory, and then that malware is extracted during the attack. So you can find out various hard-coded values, encryption mechanisms, integrity checks, any kind of telnet credentials. Not only hardware and firmware, you can find out other assets also. Some of them are having web interface available, telnet session. Some advanced equipments are coming with wireless support, so you can play with the wireless support and hacking into those equipments. If you go little level one above level 0, and somewhere around level 1 2 3, there are metasploit modules available. You can like Modbus is having some metasploits, Modbus detect, these type of metasploit modules. There are other Agora exploit packs are also available. You can play with those exploit packs. You can scan use the OT environment. There are some audit files are also available for host based audits. On the controller level, you can disrupt its operation, change the thresholds. You can disable the control equipment. You can change the RTU values. Yeah. You can play with HMI. That is what happened in the Stuxnet type of attack. People have hacked into, even in Ukraine power grid, people have hacked into the HMI. The operator did not come to know what is happening into the field, and then the centrifuges which were in the field, they were burning. Or in case of Ukraine also, HMI was hacked by somebody has taken the remote access of the entire electrical grid. You can play with the historian database. You can change the PLC logic code. Somebody can extract the engineering works, the project files, and play with it. You can do the DOS attacks on various industrial system components as well. So on little one more level up, you can do enumeration, find out what all different devices are. You can generate the asset inventory also using passive scanning. There is a low impact. There the existing some of the ID tools using the low impact options. You can do some low impact offensive ICS pen testing. Don't try to do directly with these products. It might fail. You will lose your money as well. I mean, some of the products you are directly, don't do IT type of things if you are not doing with the product. As simple as it is expecting some kind of packets on some particular port, and if you are sending the flooded packets, that device might die. So be careful and try to do anything with the low impact thing. Uh, people on the there is a main process management, and there is safety process. So you can do some kind of POCs or labs in traversing into the safety environment as well. On wireless, there is a lot of variety in the lab also you can do, or in the field. There are wireless. I personally have worked a lot with wireless HART. I have strong interest in wireless HART. You can play with wireless HART. There are tools like YNLS. You can do the packet capture. Injection is a bit difficult depending upon what type of wireless protocols you're using. So you can play with various types of wireless protocols as well. On the monitoring, if somebody, there is a lot of need. The existing passive scanning tools are very costly, and there is a lot of research also needs to be done in the OT world when it comes to the generating asset inventory, or if somebody is interested in open source tools. I just mentioned about security onion. There is no silver bullet. You can tie it with other tools like Malcolm, Snort, Suricata, IDS, Network Miner, and Wireshark, T-Shark, these type of tools, and you can develop your own algorithm to deal with the passive scanning. Uh, uh, you will have to add some protocol support. It's not that straightforward as well. This environment can be used for doing any kind of forensics. Somebody is interested in reverse engineering forensics. In ICS malware, there is a lot of variety. As I mentioned in the beginning, Stuxnet, Havoc, Flame, Black Energy, IronGate, PLC Blaster, Triton. There are many malware, and if you can get the samples, you can study and do a research also as part of your PhD study into this lab. On the defensive side, so I'm covering three secure, vigilant, and resilient defensive basically, uh, whatever environment you have created, how you can convert the environment in a more secure fashion. So you can work on various how to define the zones conduct modeling, where the DMZ should be placed, what are the safety zone considerations. uh, People are doing threat modeling as part of their ICS assessment also into the OT environment. There are tools also available for that. You can get hands on to that. You can play with the low cost unidirectional gateways. Uh, there is something called as secure PLC programming. First try to learn some basic PLC programming, and how operator should be doing the PLC programming in a secure fashion. So you can focus on that. And there are many domains you can cover uh, in a typical niche cybersecurity framework. So you can cover all the domains all the way from identify, protect, detect, respond, recover. So you can make your hands dirty with all different types of cybersecurity domains into this field. Additional things, there is something called as honeypots. I have given you some examples: corn pot, gas pot, teapot, grid pot. These are some of the examples. You can create your own honeypots. As good as some simple honeypots can be deployed inside the environment, and if a malicious activity happens, it will create a alert, and that gives you the indication that somebody is in your environment. Um if you are aware about Shodan, you can play with Shodan and try to find out remote access into the environment. This environment can be used for conducting the CTFs also, various CTFs. So SANS is running their CTF, Dragos is running their CTF, various institutes, which I mentioned, some governing bodies, they are also running their ICS CTFs. These are all various. A lot of people are bringing virtualization in the OT environment at level 2 and above. So that can be used for doing some kind of pen testing also. So you can put your hands dirty and on some of the even on the deception technologies. So deception technologies, some of the examples I had discussion with companies like RTO Network. So they are using deception technology and how it can add value. You can analyze those things in your environment. Digital twin is something new concept. It's like making your physical process uh, um, making it in the virtualized. It's like creating a digital twin of your environment. Well, a lot of back and forth discussions are happening when the topic is coming to the digital twin. So those type of research are so opportunities are also available on the digital thing. So I have 4 minutes left. I'll try to wrap up exactly by 4 o'clock. So there are challenges in this test bed. For sure, you have to follow the design guidelines and then how you can improve on this design. Try to make it as much as real world representation. If it is at a country level, you have to think it like that. Replication is safety, your choice if you want to focus on any research on the safety side. Complexity, for sure, it's a debatable topic. It's a lot complex to be done. Cost also needs to be considered, how much somebody, your sponsor, is ready to invest, and then scalability. These are all the different options. So few tips: think big, start small with the simulators, mini kits, virtualization, open source tools. Take a tier-based approach. Give a rating to your basic test bed, and then how much you have grown on the offensive, and then monitoring, and try to give rating from 0 to 100 and grow in a vendor agnostic. Make it a vendor agnostic ICS lab if you are interested. So with that. I convey my thanks to everyone. One big point I want to convey is look at from the people process technology point of view into these kind of test beds. Look from securing what you have. How can you get more visibility, and then if attack happens, how can you secure this environment tomorrow? How can you come back as soon as possible if it is a very big environment? And then third one is basically how can you integrate a passive scanning, security operations center, and asset management, these type of tools. So that holistic approach is very much needed when you are looking. There are a lot of opportunities and a lot to be done, and we, as a country and the entire world, need a lot of people in this field. So I wish you all the best, and I take this opportunity to thank everyone who attended this and to the Red Team Cybersecurity community. Thank you.
Thank you so much, sir, for expressing your thoughts and very, very valuable speech on this topic. Many more congratulations for the presentation also, sir, that you gave here in front of all our summit audience and viewers. It was a pleasure for us to witness your caliber, and your confidence made us a motivation to achieve our goals in this field also. The way you presented your ideas in such a beautiful, clear, and crisp way, especially about the robotics and pilot plant, like that. So I would like to congratulate you about your presentation of this topic, such as OT, IT, cybersecurity in critical infrastructure, few OT cyber attacks, a need for ICS security testbed classification like physical, hybrid, and virtual testbeds, more various simulators like Modpol Master and Slave simulators like Metricon, etc. So it was wonderful, sir. Amazing. So I would like to thank you on behalf of Red Team Security Summit and in myself, from my self. It's a very wonderful speech. Thank you, sir. Thank you so much for an exciting, vibrant presentation. We all enjoyed listening to your great experienced, thought-provoking words, sir. You gave an intelligent and well thought out solutions to all the current issues related with this ICS SCADA security labs. Thank you so much, sir. Now we can ask the audience about the questions or doubts if they have any doubts or questions to ask you. Audience, do you have any questions to ask for Mr. Muzail, sir? You can drop down your doubts in the Q&A section that you can see on your right hand side of your screen. You can put your questions out, sir. There is two questions. Two more questions. Testing and operation of software possible with Python. So, can you hear me? Hello, sir. Hello, sir.
Oh, sorry, I was on mute. Sorry. Okay, I'll take all of the questions. What are the different passive scanning tools available? So there is Nozomi, Clarity, CyberX, Dragos. There are at least 12 different types of dozens or more than that tools are available into this world. Uh, the main thing you should be careful that when you are doing the passive scanning, the switch should not get overwhelmed and it should not affect the existing production. So be careful while you are doing the passive scanning. Otherwise, you can do passive scanning in a port by ports, and you have to understand the environment and be careful while doing the passive scanning as well. Uh, Another question, someone is asking about the training and reading material. See the website scadahacker.com. There is a lot of material available. SANS also has a lot of material available. There are books like Hacking Exposed SCADA Security. I forgot the author name. So you can see the Hacking Exposed. Eric Knapp also is having another book. You can Andre Ginter is having one book on the unidirectional gateway. You can go through that book. Then please provide free resource of ICS SCADA freeware tool and learning because getting in this is so much expensive. This is growing and demandable field in South Asia. And okay, so tools are plenty. I would request you to understand the strategies as well. Tools will depend on what vertical you or it's a wide thing, and then you take some option and go into the depth of it. I will suggest you choose some kind of certifications also. There is GICSP by SANS, there is CSSS Certified SCADA Security Architect CSSA. ISA IEC also has come up with a program with 4 different certifications. I think one is Fundamental Specialist, then Risk Assessment Specialist, Design and maintenance, and then you get the expert level certification also. So you can do that kind of certification. Most of them are costly. The total cost will be around $6,500, but nevertheless you can still find a lot of material, white papers on scadahacker.com. Start reading it, and that will help you to put your foot in the door of ICS SCADA security. That will help you a lot. Then which thing makes SCADA networking different from normal networking according to VA and PT point of view? PT, you cannot do the PT in a typical IT type of fashion into the SCADA. As I mentioned, it's a 15 year behind than IT environment. Don't try to do any kind of PT in the OT environment. It should be a passive scanning. And when the topic comes to active scanning, it should be a selective active scanning that can be done either during before commissioning of the plant with the proper contracts in place, or in a representative environment or on backup system or on virtualization things. And you have to understand and uh, uh, don't do any kind of PT activities on the live production environment at all. That will really boomerang to you and your company as well. It's challenging there. Testing and operation of software possible with Python. Testing and operation there take an example like Python py modbus, so you can use py modbus type of utilities also. Python will help you a lot. Then any other question? How to back up critical tasks? Can you suggest some training reading materials? Okay. Operation security, any resource or link for reference or coding based on the I did not operation security, any resource or link for. I did not understand the question about operational security. Or
Okay,
somebody.
so
Okay. Yeah. I think I covered most of them.
yeah, you have covered all the topics, I think so. Thank you so much, sir, for your valuable answers, and you gave a complete clarification on the questions also. It was awesome. Thank you so much, sir. And we have a massive thank you to all our event partners, supporting partners, and community partners. Also, a big thank you to our proud community partners and tech partners. So, we would like to winding up this session, sir. And
Thanks.
yes, sir. Audience, now we are winding up
Thanks,
this
Ajila.
session, and soon we will be having an upcoming session by Mr. Nitin Bhatnagar on the topic Securing Payment Data with the Data Security Standards. The session will start at sharp 4 p.m. Please stay tuned and switch over to the next session. Have a great evening, guys. Thank you. It's
Thanks
already
all.
started this next session, so go there. Guys, you can go and check out the booths in the left-hand side of your screen also. Thank you so much. Thank you, guys.
Thanks all. Bye.